So what we did yesterday is we did the ones where it was you were given a coordinate, you plotted the coordinate, then you drew a triangle towards the x-axis, found the third side, and gave me my trig ratios that I wanted, right? Now today, I'm going to give you something very similar, but it's not going to be a direct point. Suppose theta is an angle in standard position with a terminal arm in quadrant 4. So the first thing you're going to do is draw your terminal arm in the right quadrant. So you're going to draw your terminal arm in the quadrant given. Right, what I wrote down. Okay. So the quadrant that it gave us was quadrant 4. So we're going to go to quadrant 4 and we're going to draw ourselves a terminal arm. No. It's not going to be perfectly accurate, but it doesn't matter. So you draw yourself a terminal arm and then you draw up towards the x-axis and you form yourself a triangle, just like yesterday. Terminal arm, draw towards the x-axis, forming a triangle, just like you did yesterday. Put that away, Jade. That's me throwing it on your book or in your bag. Yeah, there you go. Okay. Now, number 2. You go to the trig ratio given, and you label your trig ratio. And then your triangle. So you label your trig ratio and then your triangle. So yesterday we were always given x and y because we were given a coordinate, right? And we always had to find r. But now we might be given x and y, or we might be given x over r, or we might be given y over r, depending on what trig ratio we're given. In this case, we're given tan theta equals -1 over 5. Tan is TOA, opposite over adjacent. And remember, opposite is always y, adjacent is always x. So this is y over x. Now you have to decide, is the -1, is the 1 negative, sorry, or is the 5 negative? Because even if the 1 was with the negative, you might have to actually move the negative down with the 5. So that's why you have to draw the triangle to see if it makes sense. In this triangle, is my x negative or positive? Is my y negative or positive? My x is positive, my y is negative. So I need to move the negative sign with the y. And the only reason why I knew that is because I drew the triangle. That's why you can't skip that step of drawing the triangle. I won't give you a Cartesian plane on your test. I'll just ask you that question and you need to know to draw the triangle. Okay. So now we label our trig ratio. So we labeled it y over x, and then we label our triangle. So we have x equals 5, and we have y equals -1. Now it's obviously not drawn to scale, but that's okay. The reason why you draw the triangle is not for the scale so much as you draw it so that you know which is positive and which is negative. Okay? Now we might be given cos theta or sine theta, so we might actually get r, not just x's and y's like yesterday. Okay, we could get r if they would have given me cos or sine instead of tan. Still, the third step is to solve for the third side. So just like yesterday. X squared plus y squared equals r squared. And just like yesterday, we're solving for r squared. But like I said, we might not be solving for r squared. We might solve for x or y, depending on if we don't get given the trig ratio tan. So we know x is 5 squared plus -1 squared equals r squared. Now you guys, if you put -1 squared in your calculator, or any negative in your calculator, you have to put in brackets, right? Or else it won't change it to a positive. You can't put this all in your calculator and take the square root of it and give me a random crazy decimal, because I asked for you to determine the exact values of sine theta and cos theta. Exact values means no decimals. So if you're getting a decimal, you have to go back, try again. You can't have a decimal. So what does this give me? 25 plus 1 equals r squared. So 26 equals r squared. Now we have to square root it, and whenever we take the square root, we take the positive or negative value of it. But we know, because it's r is the radius, and the radius is a distance, and distances can't be negative, right? So r is always positive. So it's the square root of 26. We can't make that any more of a mixed radical, because I can't break 26 down into any perfect squares, like 4 times something, or 9 times something, or 16 times something. So I can't reduce root 26 down into a mixed radical. What does that mean? If I had given you, say, root 24 instead of 26, which you didn't get, so don't ask where I got this, I just randomly made it up. But say I get you, instead of 26, you got root 24. You could break root 24 up into root 4 times root 6, right? And root 4 is 2. So it'd be 2 root 6 would be your mixed number. And you're expected to do that, if you can. So you have to see if this number can break down into be divided by a perfect square, like 4 or 9 or 16, right? But 26 can't, so it just stays root 26. So I go here and I say r equals root 26. And now I can give any trig ratios they ask for. So they ask for sine theta, so over h. But remember, opposite is always y, and h is always my radius. So we do y over r. Is more appropriate for these questions, because they're centered around the units, or centered around the 0, 0 point. And then we want cos theta, which is adjacent over hypotenuse, because it's ka. Adjacent is always x, hypotenuse is always r. So we want y over r first for sine. Y is -1. R is root 26. But remember from yesterday, I told you we can't have a radical in the denominator, right? We need to rationalize it. So we're just going to multiply the top and the bottom by root 26. And so we're going to get -1 root 26 all over 26 for sine theta. You find out cos. What would cos be? And remember, you can't just put in decimals, right? Because it says exact values, and exact values is not decimals. So x is 5, r is root 26, times by root 26. And we actually get cos theta equals 5 root 26 over 26. So those are the exact values. Now, like I told you guys yesterday, I could ask this as a question. I could say, it's the exact same question. I could say, suppose theta is an angle in standard position with a terminal arm in quadrant 4 and tan theta equals -1/5. Determine the exact value of cos theta in the form a root 26 over b. What's a times b, right? Forcing you to get into this form. All right, flip over. You guys try this one out. Keeping in mind that it's cos, so it's a over h, which is actually x over r. It's not y. You have to find y. Tan x. All right. So We drew it in the third quadrant. So we draw our terminal arm out, draw it up to the x, put our theta in there, and we know we have x over r. Now, we know that the x has to be negative because the r can't be. So x is negative 3, r is 4, and we need to find y. What I do instantly is I put a negative here so I remember, hey, y is going to have to be negative because it's in that third quadrant. So x squared plus y squared equals r squared, but we're solving for y. So we're going to move the x squared over. So x squared equals r squared minus x squared. So you're going to get y squared equals 4 squared minus negative 3 squared. Y squared equals 16 minus 9. Y squared equals 7. And then you're going to square root it. And when you square root it, Anthony, what do you always have to do? Plus or? Yes. So you do plus or minus, because you could have two values. But which one doesn't work? The positive one? Yeah. So you're going to be left with negative root 7 as your y. And now we give our two trig ratios. Sine theta equals opposite over hypotenuse. Opposite is y, hypotenuse is r. So y is negative root 7 over 4. Done. However, if you did not draw the triangle, you maybe wouldn't remember that this root 7 is actually negative, and you'd pick root 7 over 4. That multiple choice answer will be there. It's wrong, but it will be there, because if you forget the sign, right? Because you put the ones that are common errors there. All right. Then tan theta is opposite over adjacent. Opposite is y, adjacent is x. So it's going to be negative root 7 over negative 3, which is root 7 over 3. Now this is positive here because tan is positive in the third quadrant. Remember? Cast, C-A-S-T, tan's the only one that's positive. So tan theta is going to give me a positive ratio, whereas sine isn't because it's not positive in the third quadrant. Okay? Now you're going to go to number 8 in your textbook, page 96, number 8, and you're going to do that. Now what it says is it gives you a table, and it gives you the trig ratio in the table, and then it gives you what quadrant it's in, and it asks for the other two trig ratios. Okay, so that's what you're going to do. Bless you. There's one that's like this. Say I gave you tan theta equals 1. Well, tan is opposite over adjacent, right? So opposite, which is y, over adjacent, which is x. What is it 1 over if it's just a 1? Yeah, 1. So if we had tan theta equaled 2, let's say, which you can't. Well, it could. Tan could. You could put 2 there, and then it would be 2 over 1. Okay, so you always put them over 1. So you do page 96, number 8. You'll have a few minutes to work on it, and then we're coming back. No. No. So we have determined the exact value of sine 135. The good thing about these is because you have the unit circle, you will have the unit circle memorized. If you don't, these you can just pull right off of the unit circle. However, if we didn't actually learn the unit circle, you guys would have to use your 30, 60, 90 and 45, 45 triangles and have to do this, which would be much more work. So because we have the unit circle memorized, and you're going to have it memorized, if you don't, or this is going to be a hard question, we're going to just draw where it would be. So sine 135 is about here. So we know that off the unit circle, because I told you this before, that your coordinates are always cos and sine, right? So x values are always cos, y values are always sine. So we're going to go to sine, we're going to go to 135, which is that one up there. And are we going to look at the x value or the y value? Because we want sine of 135. Coses are the x values and sines of the y values. So we're going to take the y value off of the 135, which is root 2 over 2. That's our answer. Move on to the next question. Root 2 over 2. Now if we want cos of 240, we'll go to 240, and we're going to look at the x value, because the x's are all the cos values of 240 and all the other degrees, and the y values are all the sine values of all the degrees. So if we want cos of 240, we go to 240 and we look at the x, because that's cos of 240, which is negative a half. Okay? Now, flip to the next page. Coses and sines are easy because you'll literally just go to the x value of that degree and write it down if it's cos. And you'll go to the y value of that degree and write it down if it's sine. Okay? But what if it's tan? Tan isn't on there, right? But we do know that tan is TOA. So tan theta is opposite over adjacent, which is y over x. Or we could say y divided by x, correct? Yes. We have y's and x at those values. So we just need to go to the 60-degree value, and we need to take the y value at 60 and divide it by the x. That's how we get tan. Okay? Stop. So you get root 3 over 2 divided by a half, which is root 3 over 2 times 2 over 1. The 2's cancel each other out because there's one on the top and on the bottom, and I'm just left with root 3 over 1, or root 3. So the answer to this one is root 3. So whenever we have tan, we have to go to that degree and take the y value and divide it by the x value. Okay? So for these questions, what you're going to do is you're going to do all the rest of them, and then we're going to go through the answers. So do that. Okay, sine of 225 is negative root 2 over 2. And then sine of 90, you always write the degree symbol beside the sine, is 1. Cos of 150, I don't know why I put that in bracket. Cos of 150 is the x value at 150, which is negative root 3 over 2. Cos of 90 is 0. Tan of 240 is y divided by x. So y is negative root 3 over 2, and x is negative a half. And the only way we can divide fractions is inverting and multiplying. So negative root 3 over 2 times 2 over negative 1. The 2's cancel, and negative 3 divided by negative 1 is negative root 3. Negative root 3 divided by negative 1 is positive root 3. Sorry. And then cos at 135 is negative root 2 over 2. And then tan at 150, this is a little bit of a trickier one, is a half divided by root 3 over 2, which is actually a half times 2 over root 3. My 2's cancel, and I'm left with 1 over root 3. But remember I told you you can't have a radical in the denominator, so you actually have to rationalize it. You have to times it by root 3, which is root 3 over 3. Your total homework that I will be checking tomorrow, including that 5 from yesterday, is page 96, number 1BD. It's on the board up there, too. 2, 3B and D, 5, 6, and 8.